Good morning. Today we are going to cover section 9.1, angles, arcs, and their measures. So take the time to copy down your title, copy down your essential question. How do you describe angles and angular movement? Go and paste your cutout and go and copy those two graphs. You can just make 4x4s and we'll start once you're ready. Go and pause it. So the definition of angles. An angle is determined by rotating a ray, half line, about its endpoint. The starting position of the ray is the initial side of the angle, and the position after the rotation is the terminal side. So therefore, we are going to have a ray that will be rotated, the half line will be rotated either up or down, and this is your initial side. Once we finish the rotation, will be your terminal side. So let's go and take the time to copy it down. We have our initial side that we rotated, and I'll place a 60-degree angle, or just around here, it's fine. And this ray, the rotation, and that'll be theta, where this is your initial side, and this is your terminal side. Now your angle can be rotated up or it can be rotated down. So for example, if I make a negative angle, if I do a negative rotation, my angle will be over here, and that'll be a negative theta. So your angles can be positive or they can be negative. Take the time to copy or paste your cutout. Copy example number 1, and we'll start once you are ready. Go and pause it. Angle measurement, degrees, minutes, and seconds. With calculator, it is convenient to use a decimal degree to denote fractional parts of degrees. And that's what you have done in geometry and in algebra 2. Historical, however, fractional parts of degrees were expressed in minutes and seconds. And we're going to be using minutes and seconds once we go into navigation with vectors and the law of cosines. So it is important to know how to convert from decimal degrees to degrees, minutes, and seconds. So let's go and start with the first one. I have negative 145.8 degrees, and I need to convert it into minutes and seconds. Well, I know that the whole part is in degrees, so therefore this will be equal to negative 145 degrees. I need to be able to find out the decimal part of 0.8, how many minutes and how many seconds. So therefore, I'm going to grab the 0.8 degrees, only the decimal part, and I'm going to convert it into minutes first. Now, if there's a decimal, then I'm going to convert that decimal into seconds. Now, we know that 1 degree is equal to 60 minutes, and this is the notation. And we know that 1 minute is equal to 60 seconds. Since I need to convert from degrees into minutes, I'm going to use this equivalency. Now, I'm using the T-chart just the same way that you guys converted decimals or units, feet into inches, yards into meters in chemistry and in physics. This is the degree, it's on the numerator, so therefore I'll place my degree on my denominator, which is 1 degree is equal to 60 seconds. That is the equivalency that we are using. My degrees are going to cancel out. So now I'm just going to multiply 0.8 times 60 and divide by 1. I'm going to use my calculator. 0.8 times 60, then I'm going to divide by 1, which is 48, correct? So therefore, this is equal to 48 minutes. Since there's no decimal part in here, that means that there are no seconds left, 0 seconds. Now let's try the next one. I need to convert 34.8175 degrees into minutes and seconds. So therefore, I know that this is going to be 34 degrees. I just need to go to find the equivalency for the decimal part into minutes first. So I'm going to use a t-chart, 0.8175 degrees. I want to see how many minutes that is. My degrees are on the numerator, so therefore I'll place my degree on the denominator, and that is equal to 60 minutes. So 0.8175 times 60 divided by 1, which is 49.05. My degrees units canceled out, so therefore this is in minutes. I'm only going to use my whole minutes. That's only 1 bar, not 2, because it's minutes. And what I need to do, I need to convert my decimal minutes into seconds. I'm going to go through the same process. 0.05 minutes. I want to convert them into seconds. So therefore, I'm going to use the following equivalency. I know that 1 minute is equal to 60 seconds. My minutes is on my numerator, so therefore I'll place my minutes on my denominator, which is 1 minute is equal to 60 seconds. My minutes units cancel out, so therefore it will be 0.05 times 60 divided by 1, which is 0.05 times 60, and therefore that will be 3 seconds. Now let's go through example number 2. We're going to be doing the opposite. We're going to convert the decimal minutes and seconds into decimal degrees. Go ahead and take the time to copy it down, and we'll start once you're ready. So therefore, this is going to be 35 point something. I need to convert the 20 minutes and 40 seconds into decimal degrees. I want to start with my 40 minutes. This will be my 40 seconds. I want to start with my 40 seconds. I want to convert them into minutes. And since I'm going to convert seconds into minutes, I'm going to use this equivalency. My seconds are on my numerator. I'm going to place my seconds on my denominator, which is 60 seconds. It's equal to 1 minute. My seconds cancel out. So therefore, whatever I get will be into minutes. I can cancel one of the zeros as well. I can simplify. And I know that's 2/3. Or I can type into my calculator. I'm going to type into my calculator, but I have to be careful that I want to make sure that if I do 40 divided by 60, it's going to give me a decimal. Now, for now, I'm going to say it's an approximation, so 0.67, but I'm actually going to be using what's in my calculator instead of rounding up so fast. So this is minutes. We have 40 seconds is equal to 0.67 minutes. So now we have 20.67 minutes that we're going to convert into degrees. So we have 20.67 minutes. We are going to convert to degrees. I'm using my conversion chart. And I'm going to use my same conversion. 1 degree is equal to 60 minutes. My minutes are on the numerator, so therefore I'll place my minutes on my denominator. is equal to 1 degree. I'm going to cancel my minute. And now I'm just going to multiply 20.67 times 1 divided by 60, or just 20 points. Now remember that I don't want to lose what I have before. So I'm going to do 20 plus my answer that I have before. So I have the exact or a little more accurate number. And now I'm going to divide it by 60. So 0.34. Approximately 0.34. I'll change this to an approximation, and this will be 34 degrees. So try letter B. See what you get, and then we can compare our answers. Go and pause it. So in this case, we have negative 20 degrees. So therefore, my answer will be negative 20. And I need to change my 30 minutes into degrees. So therefore, that'll be 0.5 degrees. Just the same way that 30 minutes is half an hour. We don't need to use a conversion chart. There's not much work to do for this one here. Example number 3. I'm going to take the time to copy it down, and then we'll work it out together. Go and pause it. So I need to perform the following calculation. We have 51 degrees and 29 minutes plus 32 degrees and 46 minutes. Now, one of the things that you have to be careful is that we want to be able to add the minutes first. So we have 29 minutes plus 46 minutes. That gives me 5, carry 1, and that gives me 75 minutes. I'm going to change this into a degrees in minutes. We know that 60 minutes is 1 degree, so therefore this is the same as 1 degree and 15 minutes. Do you agree? The same way that 75 minutes is equal to 1 hour and 50 minutes. So now I'm going to add my degrees. So it'll be 83 degrees. So therefore this is equal to 84 degrees and 15 minutes. Now, what if I subtract what is 90 degrees minus 73 degrees in 12 minutes? Now, if I want to subtract, I'll place a bigger number on the numerator. Now, be careful. You want to be able to make separate and subtract them separately. So this is going to be separated. And I need to subtract 12 degrees from nothing. So therefore, I'm going to take one of the degrees and convert it into minutes. So therefore, this will be 89. The same way that you subtract and you borrow. So this will be 60 minutes. Correct? 89 degrees in 60 minutes is equal to 90 minutes. And now I can subtract. So this will give me 48 degrees. And this will give me 48 minutes. And this will be 14 degrees. So this is equal to 14 degrees and 48 minutes. Go ahead and take the time to paste your cutout and your small unit circle. Go ahead and pause it, and we'll start once you are ready. Now you should also have received this with you. So I'm going to place it in the center. Flip it over. And open it up. And therefore you have a functioning angle. So we've done, and you learned this back in Algebra 2, a measure of 1 degree is equivalent to a rotation of 1 over 360 of a complete revolution about the vertex, which means that there are 360 degrees all the way through. To measure angle, it is convenient to mark degrees on the circumference of a circle, so a full revolution counterclockwise corresponds to 360 degrees. Half revolution is 180. A quarter revolution is 90. So let's go start to label your unit circle. So a full degree is, so this is 0 degrees, and a full degree is 360 degrees. Halfway through will be 90. But not 90, 180. A quarter is 90 because that's a 90-degree angle. So therefore, you have 90, and 90 more is 180, plus 90 more will be 270 degrees. Plus 90 more will be 360. Next, I'm going to work through my 45 degrees. This is 45. Plus 45 is 90. 90 plus 45 will be 135. Plus 45 is 180. Plus 45 will be 225. Plus 45 is 270. 270 plus 45 will be 315. Plus 45 will be 360. Next will be, I want to divide my 90 into 3 sections. So therefore, this will be 30 degrees. Plus 30 more will be 60. Plus 30 more will be 90. Plus 30 more will be 120. 120 plus 30 is 150. Plus 30 is 180. 180 plus 30 is 210. Plus 30 more is 240. 270. Plus 30 more will be 300. Plus 30 more will be 330. Plus 30 more will be 360. And that's how you want to think about it. 30, 60, plus 30, 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 plus 30. 45, plus 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 45. So therefore, if I say, where's 300 degrees? I say, well, I know that this is 270 plus 30 degrees more is 300. If I say, where's 240? I say, well, I know that this is 270 minus 30 more is 240. Coterminal angles. Coterminal angles are angles with the same initial and terminal sides. Go and copy it down, and we'll start once you are ready. We are not going to sketch it. We're just going to find the least positive coterminal angle. And we are just going to use our unit circle. So coterminal angles, if I have 135, I need to find another angle that has the same measurement. So therefore, that lands on the same location, the measurement will be different, but the location will be exactly the same. So therefore, if this is 135, to land on the same location, I need to go all the way around, and those two angles are exactly the same. And I can go again all the way around, and you'll have a different measurement, but the angles will be exactly the same. Those are coterminal angles. So therefore, what do I need to do? Actually, let's go make a quick sketch since we have it here. I'm just going to make it 3 by 3 or a 4 by 4. So 135 degrees is here. So what do I need to do to find a coterminal angle? I need to add or subtract 360. So therefore, I'll take 135. And since I need a positive coterminal angle, I need to add 360 degrees. If you need to find a negative coterminal angle, you can subtract 360 degrees. Therefore, this gives me 0, this gives me 9, and this is 400. So therefore, this is 135 degrees, but it's also 495 degrees, if I can add it correctly. 5 plus 0 is 5. That is correct. So therefore, 135 and 495 degrees land on the same location. And if you don't have a label or you don't have the low rotation symbol, you will not be able to tell the difference. Letter B. I'll make a quick 4x4. First, you need to locate where is 300 degrees. Well, I know that this is 270, so 30 degrees more is around here. Now, when I do my 30 degrees, I place 2 dashes that are evenly spaced, and I know that this is 30 degrees. I'm going to place my rotation. I need to find another positive coterminal angle. So therefore, what do I need to do? I need to go all the way around again to land on exactly the same location. And we know that all the way around will be adding 360 degrees. So therefore, that new angle will be 660 degrees. And those two angles will be exactly in the same location. Letter C. I'm going to place a quick 4x4 graph. First, I need to locate where's negative 120 degrees. So negative 120, that means I have to go backwards. I know that this is negative 90. How much more to get to negative 120? 30 more. Remember, when I do my 30 degrees, I place my 2 dashes evenly spaced, and therefore this will be negative 120 degrees. Now, I need to find a positive coterminal angle, so therefore I need to add 360 degrees. That means I'm going to be adding 360 degrees, and I'm going to land on the same location, and that'll give me positive 240 degrees. So this is negative 120 degrees, but 240 degrees will land exactly on the same location. Go ahead, paste your cutout, example number 5, and we'll start once you are ready. Go ahead and pause it. Complementary and supplementary angles. Two angles are complementary if their sum is equal to 90 degrees. Two positive angles are supplementary if their sum is equal to 180 degrees. So if possible, find the complement and the supplement of 20 degrees. So what is the complement? And what is the supplement? And you learned this back in geometry, correct? So what is the complement of 20 degrees? That'll be correct, 70 degrees, because together they are up to 90. What is the supplement of 20 degrees? 160, because together they are up to 180. So what is the complement of 75 degrees? Correct. This will be 15 degrees, because together we're up to 90, and supplement will be correct, 105 degrees. So definition of radians. Take the time to copy your cutout, radian measure, your 4x4 graph, and your unit circle. And we'll start once you're ready. Go ahead and pause it. So 1 radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius r of the circle. Algebraically, this means that the degree that is going to be equal to S divided by the radius. And we're going to come back to this formula once we do a few applications on letter sections, where theta is measured in radians. So therefore, if you take an arc of length S equal in length to the radius of the circle, I'm going to use this same thing that we're using on the last circle. And if I take the radius, which is from here to here, and I wrap it around the circle, that is 1 radian, which is about 57 degrees. 57, it's around 57.2 degrees. We're going to say 57 degrees. That is going to be an angle, which is 1 radian. And if I take the same radius and I wrap it around again, that'll be 57 plus 57 will be 114 degrees, which will be around here. That'll be 2 radians. And if I do it once again, if I take my radius and I wrap it around the circle, that'll be 3 radians. Which will be 57 times 3. Will be 171. We don't make it all the way through because how many radians is halfway through? Correct. 3.14, which is pi. Let me go and place my arrow that you should have with you in the center. And let's go and draw just 1 radian, which is about 57. So 30, 60, 30, so 57 is around here. That is 1 radian, which is approximately 57 degrees, well, 57.2 degrees. Now, the way that you want to be able to think about your radians is, we know that halfway through is 1 radian. Therefore, if I rotate it all the way through, it will be another radian, so it will be 2. So halfway through will be 3.14, which is pi, all the way around will be 2 pi. Right? So it's 1 radian, 2 radians, 3 radians, 3.14, so it's pi. All the way around is another pi, so it's 2 pi. And if I take pi and I divide by 2, that's halfway. Therefore, that'll be pi over 2. So 90 degrees is the same as pi over 2 radians. So I can say this is 1/2 radian, 1/2 pi. This is 2/2, which is pi. This will be 3/2. So 270 is 3 pi over 2. And another half will be 4/2, which is 2 pi. So this is 1/2, 2/2, 3/2, 4/2. Next will be the pi over 4. I'm going to take my pi and I'm going to divide it in 4 sections. So therefore, this will be pi over 4, 1/4. This is 2/4, which is 1/2. This is 3/4. So therefore, this is 3 pi over 4. This is 4/4. This is 5/4. 5 pi over 4. This is 6/4. This is 7/4. 7 pi over 4. And this will be 1 more fourth, will be 8/4, which is 2 pi. Next, I'm going to do my pi over 3. I'm going to divide my pi in 3 sections. This will be 1/3, which will be pi over 3. So this is 1/3. This is 2/3. This is 3/3. This is 4/3. This will be 5/3. And 1 more third will be 2 pi, which is 6/3. Now, your thirds are usually a little more challenging for you, but you want to be able to think that pi over 3 is your 60 degrees. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Next will be your pi over 6. I'm going to divide my pi into 6 sections. This will be pi over 6, 1/6. This is 2 sixes, which is 1/3. This is 3 sixes, which is 1/2. This is 4 sixes, which is 2/3. This is 5 pi over 6. This is 1 more 6 will be 6 sixes, 7 sixes, 8 sixes, which is 4/3, 9 sixes, which is 3 over 2, 10 sixes, which is 5/3, 5 pi over 3, 11 pi over 6. Remember that you want to be able to think about this in that form. So if I say, where is 7 pi over 6? Well, I know that this is 6 sixes. To get to 7, I need 1 more 6, and you know where the location of the angle. Example number 6. Sketch the measure and find the coterminal angle. So we cut the coterminal angle in degrees, but now we're going to do it in radians. 2, 4, 2, 4. We'll make quick 4x4 graphs. Go and pause if you need more time. I need to know where 5 pi over 6 is. So what you want to think about is that you know that this is pi. So how many 6s are in 1 pi? 6 sixes, correct? So therefore, if this is 6 pi over 6, 5 pi over 6 is 1/6 less, which is 30 degrees less. I'll place my two dashes, and 30 degrees will be 4. And I'm going to place my rotation. Now, how can I find a coterminal angle? That is the question. So to find a coterminal angle, what do I need to do? Right. I need to add 360 degrees. Or in radians, we know that 360 degrees is equal to 2 pi radians. So therefore, I just need to be able to add 2 pi. And in order to add them, I need to be able to make into a fraction over 1. I need to have the same denominator, so therefore, multiply by 6 gives me 12 over 6. So therefore, this will be 17 pi over 6 will be a coterminal angle. That means that I went all the way around and landed on exactly the same location. Example B. Negative 5 pi over 6. That means that I need to go backwards. And if I go backwards, I know that this is negative pi. And this is negative 6 over 6. I need negative 5 pi over 6. So therefore, will be 30 degrees less. So therefore, it will be located along here. And to find a coterminal angle, I can add or subtract 360. I'm going to add 2 pi. Because this is 6x, this will be 12 pi over 6. So therefore, a coterminal angle will be 7 pi over 6. And yeah, so that looks like a 7 pi over 6, correct? That means that I went around 360 degrees to land on exactly the same location. And letter C, where's 2 located at? Correct. 2 is located, it's not 2 degrees because it doesn't have a degree symbol, it's 2 radians. Remember, 1 radian is about 57 degrees. 2 radians will be 114 degrees. That is 2 radians. What do I need to do to find a coterminal angle? I need to add 2 pi. So therefore, it will be 2 pi plus 2. Will be the exact answer. Now, if I need an approximation, then I can just use a calculator and I just place 2 times pi, which is 6.28, and add 2, which will be approximately 8.28 radians. I don't need to place, I can write down word radians, or I can leave it as is without a degree symbol. Example number 7. If possible, find the complement and the supplement of pi over 6. Now remember, why does it say if possible? That is the question. Well, if you go back to your definition for complementary and supplementary angle, they must be both positive. 2 positive angles and 2 positive angles. So therefore, is there an angle? First, let's find the complementary. Then the supplementary. So what do we need to add to pi over 6 to end up with a 90-degree angle, which is pi over 2? What do I need to add to pi over 6 to end up with pi over 2? Correct. I need to add 2 pi over 6, which is the same as pi over 3. So if you add pi over 6 plus 2 pi over 6 gives me 3 pi over 6, which is 1/2. Remember that 90 degrees is equal to pi over 2. And remember that 180 degrees is equal to pi. So therefore, what do we need to add to pi over 6 to end up with pi? 5 pi over 6 will be the supplementary angle, or the supplement. So complement and the supplement. So what is the complement of 2 pi over 5? So what do we need to add to 2 pi over plus what do we need to add to end up with pi over 2? What do you think it is? Well, I need to end up with pi over 2, correct? So I basically need to end up with half. I need to end up with half a pi. So therefore, I need to end up with, now we can write as a decimal, or I can just convert this into 4 pi over 10. And half will be 5 pi over 10. So therefore, I just need to add pi over 10. Will be the supplement. The complement. The supplement, I need to add to pi, so therefore I'll be needing 3 pi over 5. And if you want to confirm, we know that 2 over 5, I can use my fraction bar, 2 over 5 plus 1 over 10 to give me 1/2, and it does. Now, to do conversions, to convert from degrees to radians, you can multiply by pi radians over 180 degrees. And to convert from radians to degrees, you can multiply 180 degrees divided by pi radians. So go and paste your cutout, copy example number 8, and we'll start once you are ready. Now, instead of memorizing what I need to multiply by, I prefer to do a conversion table that we just did on example number 1. And I need to change 100 degrees into radians. So therefore, I need to find a conversion. And the conversion unit that we're going to use is that we know that pi radians is equal to 180 degrees. My degrees are on top, so therefore I'm going to place my degrees on my denominator. And 180 degrees is equal to 1 radian. So therefore my degrees symbols cancel out. And I can simplify, or I can multiply across. 100 times 1 is 100 over 180. I can reduce my fraction, cancel one of the zeros, divide by 2. So this will be 1, this will be pi radians. Look at my pi here. So this will be 5 pi over 9. 420, I'm going to go through the same process. I know that 420 degrees, my degrees are on top. My degrees will be on the denominator. The 180 degrees is equal to pi radians, or just pi. my degrees cancel out. I can cancel one of my zeros. So therefore, this will be equal to 42 pi over 18. I can reduce by 2. So it gives me 21 pi divided by 9. I can divide by 3. Therefore, this will be 7 pi over 3. Now, to convert from radians to degrees, we're going to go through the same process. This is going to be 5 pi over 3. I'm going to extend my fraction bar to be my table, my conversion table. Radians are on top, so therefore I'll place my radians on the bottom. Pi is equal to how many degrees? 180 degrees. My pi is canceled out. I can multiply and then divide first, or I can simplify my fraction first. So I'm going to divide by 3. So it cancels, and that gives me 60 degrees. So 5 times 60 will be 300 degrees. 3. Remember that this is 3 radians. My radians are on my numerator, so therefore my radians will be on my denominator, and that is equal to 180 degrees. So therefore, I can change it, have it as a 240 of 324, 420 degrees over pi, or I can use my calculator. And if I need an approximation, 3 times 180, 540. And you know what's doing my math wrong. So I'll be 540 divided by pi. And that'll be approximately 171.9 degrees. And remember that this is 1 radian, 2 radians, and this is 3 radians, which is 171.9 degrees. And that is the lesson for today. Have a great day. Email